start হয়ে যাবে
সেটা স্টার্ট হয়েছে না অফ হয়েছে এই তো চলছে চলতে
ওইটা মানে স্টপ হবে স্টার্ট হয়ে গেছে
চলছে কিনা
Okay, so I was actually discussing on let me tell you some requirement about this please, because you see that for all the subjects, all the topics, all the modules in your course, you have to understand first that what is the requirement, what is the application. Then only you will be able to understand what is going on there. Okay, so in this chapter I was actually discussing for the last 3 classes, that is air conditioning. So regarding this I have discussed the properties of the mixer. Properties of the mixer means basically properties of the air is what basically? Air is basically mixture of gases, and that was basically dry air and water vapor. So the property of the atmospheric air, that is called atmospheric air. Property of atmospheric air will be combination of the dry air and moisture. Okay, and we have seen that the atmospheric air can be considered as ideal gas, both the dry air as well as the moisture. And we have seen several temperatures like dry bulb temperature, wet bulb temperature. So say dry bulb temperature, this one is dry bulb temperature, wet is simply a thermometer without anything else. This dry bulb is, this is the bulb of the thermometer. It contains the thermometric fluid, and here basically we touch the object to measure the temperature. So for atmospheric temperature it is open in the atmosphere. So here we get the temperature for the dry bulb temperature. This bulb is covered by some wet wick, and the temperature will drop from the dry bulb temperature like this. This is the same as this. So this is called wet bulb temperature. Air will flow and make the air. This air is unsaturated, but when it keep on flowing, then it will absorb moisture from the wet wick, and therefore the moisture will be added to the air, and air will become saturated with the moisture. And what will happen here, since the moisture is evaporated, absorbing the latent heat of evaporation from the wick surface, then the wick surface temperature will drop, and since the wick is in thermal equilibrium with the bulb, then the bulb temperature will be also same as the wick temperature. Okay, and the final temperature when the moisture will be the air will be basically saturated with the moisture, at that temperature we call it wet bulb temperature. So this is TWP, wet bulb temperature. Next we have a temperature called dew point temperature. That also we have started. Dew point temperature. So from this, if it is cool, then it will heat this at the constant vapor, that is partial pressure of vapor, that will heat here, and therefore this temperature is the saturation temperature corresponding to this pressure, because you see that this is the saturation temperature. So this is called the dew point. Okay, so 3 temperatures we just have seen. PD, saturation temperature at PV means this is the partial pressure of vapor. So this is T saturation temperature at PV. These are very crucial to understand that what is basically happening. So that you have to understand that what is the meaning of basically constant saturation, that is constant vapor pressure or constant partial pressure of vapor. When it will be constant, basically when the air is actually containing the same amount of moisture. Basically, from the Dalton's law of partial pressure, what is the meaning? Partial pressure of one element is the partial pressure of one constituent is what? That the pressure will be given by this when it is physically staying alone. When it will be kept alone at the same volume and at the same temperature in a particular space. Say for example, you have say n number of components. Now one by one you are keeping the components in the same volume and in the same temperature. Then the pressure given by this element or the pressure given by that component will be equal to the partial pressure of that component. Okay. Therefore, when the partial pressure is constant, that means basically the amount, that is the mass of that component is not changed. If the partial pressure is constant, that means the mass of that component will also not change. That means in a vapor, in an air, atmospheric air, when this is constant, that means moisture amount is not changed. The amount of moisture is keeping fixed. Therefore, in a particular atmosphere, so if the moisture is not added or moisture is not separated, its specific humidity will remain same. And if its specific humidity remains same, what will remain same? Therefore, the partial pressure of vapor will also remain same. It will not change because the pressure created by the element, the pressure created by the component is not changed. Therefore, the pressure will not change. Okay. Now, in the last class we have derived this, that is called adiabatic saturation temperature. So, from this initially non-saturated or unsaturated air, and at the exit it will become saturated by absorbing the moisture from the water surface. So, water will evaporate from this and it will saturate the air. So, at this the relative humidity is 100%. So, relative humidity gives you what is the relative amount of moisture that it can exist and that is existing. Okay. And that omega is the specific humidity. So here, can you tell me that from this point to this point, what will happen to the specific humidity? Will it increase or decrease or will remain the same? Increase क्योंकि moisture add हुआ है ना. You have added moisture, therefore the specific humidity will increase. Relative humidity is also increasing because you are adding moisture. So from this the moisture added percentage is increasing. So relative humidity is increasing. But you cannot directly say that relative humidity increases. Why? Because you see that from this to this, if the temperature would have been also increased, from this to this, if the temperature also would have been increased, then you cannot say the relative humidity whether increased or decreased. You cannot say. Clear? Because relative humidity depends on what? Temperature. Right? Relative humidity means what? Basically the amount of moisture that is currently present divided by the maximum possible amount of moisture that can be present at the same temperature. That means at this particular temperature, what is the maximum possible amount of moisture that the air can hold? So related to that, what is the existing amount of moisture? That is relative humidity. Right? Now therefore, if just by adding moisture you cannot ensure that the relative humidity is increased. Because if the temperature is also increased, that means humidification and heating. In that case, you cannot say relative humidity increases or decreases. We will see that. In the diagram called psychometric chart, we will see that. You see, Dryger temperature increases in this direction. From this to this, Dryger temperature increases, and the specific humidity increases in this direction. So if I add moisture and also heat, so this process will be called basically heating and humidification. Let me show it. This one. This is called heating and this is humidification. Humidification find. So heating and humidification in both are done simultaneously. Then it will be like this. And in this direction, you see the relative humidity is constant. Relative humidity is constant. Okay. So actually, I had given you the charts. I had given you the diagrams. These diagrams, right? These diagrams I am giving you. You can see that here all these lines are basically constant relative humidity line. 100%, 90%, 80%, 70%, 60%. All these are basically constant relative humidity lines. So you can see that along these lines, the heating and humidification is done, and also this is constant there is constant relative humidity line. So therefore this is a constant relative humidity line, this is 100%, and here it will be say 90%, then 80%. So you see that along this line it is tangential to constant relative humidity line. Therefore if you add moisture and at the same time you heat it, then relative humidity may remain constant. Okay, or if you say add moisture and you heat more than say the value for which the relative humidity may remain constant, then the relative humidity may drop. Say for example, you are going for a heating and humidification in this direction. Say heating more but humidifying less. You are adding moisture less but heating more. What will happen? It will be like this, and in this direction you can see the relative humidity drops. Along the tangential direction, the relative humidity is constant, but along a direction like this, if it moves from this to this, the relative humidity drops. So just by adding moisture, you cannot conclude that relative humidity will increase. Is it clear? So from this you can see that you are adding moisture. Just means adding means what? You are basically allowing the moisture to be added or absorbed in the air. So you are basically adding, you are allowing the air to get the moisture. And from this to this, the moisture quantity increase. We can clearly say that we are basically increasing the specific humidity. And at the same time, here we can say that relative humidity is increasing. Why? Because this channel is insulated. This channel is insulated. So what will happen? There is no question of heating. We are not heating. We are not increasing the temperature. Whatever is happening, what is happening here? The air is absorbing the moisture. Try to understand. Air is absorbing the moisture. Okay. Now moisture is what? From liquid it will be evaporated to what? Vapor. Now what will happen therefore to the water? What will happen to the water temperature? It will drop. Because it is absorbing the moisture from the either this water or this air itself. So air is going and the moisture will basically get the extra heat from water or air. Air is heating the water and then it is increasing. So what will happen therefore? The temperature of the air will drop. It will not increase. We were thinking of heating and humidification. So in that case temperature would have been increased, but here what is happening? Temperature is dropping. So surely the relative humidity also increase, and gradually it is increasing to 100%. Okay. Therefore, what will happen to T2? Can you tell? T2 is greater than T1 or less than T1? T2 is above T1, greater than T1. Or because it is, you see, from air the water is evaporated by absorbing heat from the air. So where will the heat come from? From air. So the air temperature will drop. Isn't it? Because there is no heat source. Because you have insulated this. So there is no other source of heat. So whatever water has to evaporate temperature will drop. That is why T2 will be always less than T1. You see, T1 is here and T2 is here. So it is dropping, right? And this is happening adiabatically. So this process is basically happening adiabatically. Okay. And since this is an irreversible process, we have shown with gas giants. Okay, so that calculation part also we have seen in the last class. So actually that requires the conservation of mass and conservation of energy. So conservation of mass and conservation of energy. From that, conservation of mass means basically in case of mass there are two things, two components. Here dry air plus moisture. Here also dry air plus moisture. Here is only water. So for that, basically air plus moisture, that is dry air plus moisture. Dry air plus moisture, here it is water. And for conservation of energy, here it is dry air plus moisture. It is only water. It is only dry air plus moisture. So these are similar. Okay, so white bulb temperature. So we have seen four temperatures. One is dry bulb temperature, another is white bulb temperature, another is liquid temperature, another is basically adiabatic saturation. Adiabatic saturation temperature is little above the white bulb temperature. Sorry, dew point temperature. Okay, and these are the thing that is specific volume of what? Basically, specific volume of the atmospheric air. So if I write similar to basically, you please take the printouts of this for studying. Psychometric chart. Because in this course you have, in all modules there is some chart and you have to learn how to see the charts, right? Okay, so specific volume means what basically? Specific volume.
सर আমাদের যে বইটা আছে না ওটার পিছনে চার্ট আছে সাইকোমেট্রিক চার্ট ওটা ঠিক আছে স্যার ওইটাই
প্রিন্ট করে রাখতে হবে কারণ কি আলাদা করে ক্লাসে আসতে সুবিধা। So this is the specific volume of the air and dry air and moisture mixture. So basically mass of total of what? Mass of the mixture is equal to mass of dry air plus mass of moisture. Okay. Now what is this? M that is mass, total mass. So total mass, how can I write that? Like say enthalpy. Total enthalpy of the mixture is equal to enthalpy of dry air plus enthalpy of moisture. So this is what basically specific enthalpy of the mixture multiplied by mass. Mass of what? Sorry, we will not actually do this. So we write like this and then we split this. So it is Ma H plus MW H. Now we divide by this. The whole quantity we divide by this. So this by Ma. That we write as simply H FW by MA is equal to W, that is specific humidity. So this is the relation for the enthalpy. Okay. Now similarly, this specific volume of the mixture is equal to specific volume of dry air plus mixture multiplied by specific volume of properties are similar, right? So total volume, in terms of total volume you can write, you write total volume in terms of that partial volume of partial. Like that. So it is basically dA is equal to MA to dA plus M W dW. So if I divide by MA, then it will become D by MA is equal to small v is equal to this is dA plus W multiplied by K. So what is the W? W is equal to M of W divided by M. That is the definition of specific humidity. That is the definition of specific humidity. That is the mass of moisture divided by mass of dry air. That's called specific humidity. Okay. So this is specific volume for the atmospheric air per unit mass of dry air. Per unit mass of dry air. It is specific enthalpy of the atmospheric air, that is total enthalpy per unit mass of dry air. This is constant wave temperature. And see that these are almost parallel. These are experimentally observed basically. These are almost parallel. So constant enthalpy lines and constant vapor temperature lines are almost parallel. These are almost parallel. And we have seen in earlier diagram one thing, another thing. For the moisture, this is for moisture. So moisture, and there is a specific humidity, specific enthalpy for moisture is almost parallel to the constant enthalpy. Sorry, constant enthalpy line of moisture is almost parallel to the dry bulb temperature. This is the dry bulb temperature. So this temperature is dry bulb temperature. So for moisture, the specific enthalpy, constant enthalpy lines are almost parallel to the dry bulb temperature, and for the atmospheric air, the enthalpy, this is for atmospheric air, and that line was for vapor, only vapor. So these are almost parallel to the void bulb temperature. These are actually experimentally observed. Okay. So this one phi constant line means what is phi? Relative humidity. Okay. So these are the thing. This chart is called the psychometric chart. So this is not like available in the form of table. This is available in the form of chart. So when we need to do some process, then we will just plot the process on this, and we will draw the diagram. Say for example, this is a constant dew point temperature. I was telling constant dew point temperature means constant specific temperature. Okay. This means constant dew point means everywhere. You see, the meaning is that if you start from here or here or here, dew point is here. Isn't it? Is it clear? Say the cooling, you start from here or here or here. It will follow the same constant pressure line and it will arrive at this point. So for all these, it is a constant dew point and constant humidity is constant. So constant dew point temperature means constant specific humidity. Is it clear or not? To all, is it clear? This is very crucial. So along this line everywhere the dew point is constant because dew point is here. So dew point means basically what? If you start from this point, cool it at constant pressure, it will arrive here. If you start from this point, it will arrive at the same point. If you start from anywhere, it will arrive at the same point. That means from all this it is constant dew point line, and constant dew point means basically pressure is constant. And if the pressure is constant means the element or the component which is causing the pressure, amount of that is constant. Therefore, if the amount of that is constant, that means the mass of this moisture is constant, and therefore this is constant. So constant dew point temperature means constant specific humidity line. Because this is not changing. If this is changed, then this will change. Clear? Yes. Now, if you change the temperature, the relative humidity will change. Can you tell me one thing? Say for example, along this line, I'm just asking you one important question, conceptual question. Along this line, the specific humidity everywhere is constant, and the dew point is constant. Now, say here and here, if I take 2 points, here 1 and here 2, which one is having more relative humidity? এখানে আর এখানে কোনটা রিলেটিভ হিউমিডিটি বেশি হবে? রিলেটিভ হিউমিডিটি তো কনস্ট্যান্ট থাকে না। along this line relative humidity will remain constant or change? Constant रहेगा। देखो কি বললে তুমি? সব ওয়ানে আছে। আচ্ছা আমি এখানে মার্ক করতে পারি না? এখানে 2 বলছি, এখানে এই পয়েন্টে আছে। চালু করো কেয়ারফুলি। ওটা দুটো অ্যাপ্রোচ করছি। এটা ধরো 1 এটা 2। So which one will have more relative humidity? बोलो सेम रहेगा। टेम्परेचर चेंज कर रहा है ना, टेम्परेचर चेंज कर रहा है, फिर भी मॉइस्चर सेम है। टेम्परेचर इज डिक्रीजिंग, फॉलो केयरफुली। टेम्परेचर इज डिक्रीजिंग but the amount of moisture remaining the same. What will happen? Saturation से क्लोज हो गया ना, मॉइस्चर सेम रहा लेकिन उसका टेम्परेचर ड्रॉप हो गया। Humidity there are two different humidities. One is specific humidity, another is relative humidity. So जो भी बात करना है उसको प्रॉपर टर्म यूज कर सकते हैं। स्पेसिफिक ह्यूमिडिटी क्या रहेगा? कांस्टेंट रहेगा। तो स्पेसिफिक ह्यूमिडिटी कांस्टेंट एंड स्पेसिफिक ह्यूमिडिटी कांस्टेंट मींस व्हाट? MW is constant. टेम्परेचर कम कर रहा है। From this there is the temperature decrease because here it is T1, here it is T2. T2 का और एंगल करो। So from this to this, temperature is decreasing, dry bulb temperature. So what will happen to relative humidity? Oh, up there. Definition. If you understand the definition, it will be very easy.
relative humidity माने तो
Relative humidity means what is the relative humidity at this point?
100%.
100%. Here less than 100%. So in this direction relative humidity is increasing or decreasing? Increase করছে, increase করছে।
Relative humidity increase.
Relative humidity will increase, specific humidity remains constant. Now you can see it from the psychometric chart. Can you see? Constant dew point temperature. In this direction, what is happening to relative humidity?
Very constant.
In this direction.
तो constant
अंदर lecture से ना पर ये 100%, 90%, 80% इतने कुछ ना
decreasing.
ये क्या होगा? ये बात ना
increase हो गई।
ये बात what is happening to dry bulb temperature को दिखे बेशी ये कम dry bulb temperature दिखे कम तब ना dew point reach করছে মানে dry bulb temperature কমছে না বাড়ছে? কমছে। dry bulb temperature কি হচ্ছে কমছে so T1 is more than T2 say this is say 2 so T1 is more than T2 that means it is moving in the right direction in the cytometric chart so if it is moving like that following a constant dew point temperature dew point line or constant specific humidity line then what will happen to specific relative humidity increase করবে see ও ফায়ার ফিজিক্স গুলো হয়ে যাচ্ছে a driver temperature with this line in this direction it increases in this direction it decreases driver temperature now if you follow a constant dew point temperature line in this direction say consider this is the direction in this direction so what is happening dew point temperature remains constant but what is happening to relative humidity বাড়ছে না it's increasing so what is basically doing air becomes more and more hunger when its temperature is increased because it can accept or absorb more moisture so if I increase the temperature with the same amount of existing moisture it will become more and more hunger so as if air hunger index increase कर रहा है मतलब उसका specific relative humidity increase कर रहा है yeah so you are say for example you can say eat more than him but the same amount of food what will be your relative humidity less but I have given same amount of moisture to both of you since your hunger that means temperature is more so relative humidity is less his acceptance capacity is less that is why whatever I have given he is saturated with it but you are not saturated because your hunger is more you can accept more so with higher temperature with the same amount of moisture your relative humidity is less but it is not that specific humidity is same because specific humidity means what same for this both of you same for both of you but since the relative humidity is defined as mW by mg since mg is more because at the same temperature it can accept more maximum possible capacity is more so the denominator increases that is why the relative humidity will drop clear or not clear so cytometric chart constant relative humidity lines constant dew point means constant specific humidity okay constant wet bulb temperature constant enthalpy lines constant specific volume lines specific volume and enthalpy these are for atmospheric air means whenever we calculate some property this is for the mixture and definitely wet bulb temperature dry bulb temperature these are also for mixture clear and one thing is that at this point all the temperatures are same this is one key understanding for cytometric all the temperatures are same at the value of 100% relative humidity that means what if 100% relative humidity is achieved then the dry bulb temperature is same as wet bulb temperature because there is no difference in saturation so from dry bulb to wet bulb there is no change isn't it so the air that is passing through the wick of the wet bulb thermometer the moisture it cannot accept because the air is already saturated right so wet bulb temperature is same as dry bulb temperature again regarding the dew point means if you further just decrease a slight temperature infinitesimal temperature then only the dew point will be achieved and then it will start condensing so that is dew point is same as this so that means with the relative humidity is 100% these three temperatures are same okay and also it will be same as adiabatic saturation temperature so here actually in the saturation process adiabatic saturation is not given shown okay Rishabh is it clear sure हिंदी में बोलने का आज कॉमन क्लास बाद में करेंगे आगे टाइम में Okay. So basically, what is the requirement of this? Only for passing exam? Is this for passing exam only? No. You have requirement. Say when you go for air conditioning. What is the meaning of air conditioning? I told you in the first class. Air conditioning has basically three parameters. One is the air temperature that we call derived temperature. In case of air conditioning, we call it derived temperature. Another is the amount of moisture, humidity control. So not only controlling the temperature is enough, you have to control the humidity also, because if the humidity is very small or very less, then we will feel dry. Right? There will be too much evaporation from the surface and we will feel dry. If the relative humidity is too much, then we will feel sweating and the sweat will not be evaporated easily. Because sweat evaporation depends on the relative humidity. And if I am sweating due to temperature, high temperature, but I am not able to evaporate that sweat, then what will happen? I will not feel enough comfort. So, relative humidity is also one important parameter. Another is motion of air. So, to just relieve the moisture or evaporate and just what should I say? We should carry away the moisture within and fresh air should come in contact with my body. So, there should be basically air motion. So, three things are there important. So, here what we will do basically, there are processes I have just shown you. These are the processes. Cooling means basically reducing the driver temperature. Cooling along this direction, what happens to dew point temperature? I will ask again and again to insist that your understanding is proper. Follow. What will happen? The dew point temperature along this direction. Right, increase, decrease, and dimension. This is the only three options. क्या बोला? Dew point temperature constant है I just mentioned. You have forgotten. That means what? You are not understanding it. Isn't it? Just I have shown in the last slide.
And dew point constant अगर specific humidity was
Specific humidity, if it is constant, that means dew point is constant. For the same dew point, the specific humidity is same because moisture is not separated yet. Okay. You see, I am repeating the same thing. So it is called cooling. I am reducing the driver temperature. It is called cooling. Increasing the driver temperature. This is called heating. So two opposite processes. Now I am adding moisture. This is called humidification. So it is called cooling, it is called heating, it is called humidification, it is called dehumidification. When I am separating out moisture. So heating, humidification means basically you are boiling water and mixing with say air. That will add the moisture. Now dehumidification means what? You are basically cooling, you are basically separating out moisture. So this is dehumidification. Therefore, cooling and dehumidification will go together. Okay. In general, cooling and dehumidification will go together. So what will happen basically? We will add one cooling coil. Try to understand. We will add on cooling coil. This cooling and dehumidification will go together. Because you see that when you add a cooling coil, and the temperature of the cooling coil is below the dew point temperature. Below the dew point temperature, what will happen? Over the cooling coil surface, there will be basically separation of moisture, condensation. Isn't it? If the temperature of the cooling coil surface is below the dew point temperature, the air that is coming, the moisture in this air will start condensing, and therefore the moisture will be separated. So now the dehumidification will be done. Is it clear? So cooling and dehumidification are done together, and heating and dehumidification are also done together. when we add moisture, at the same time we heat the air by some heating coil, right? So these are the processes. So in exam it may come that show the process of that is heating and humidification. So you have to show this heating, humidification, and this is the resultant of this. Clear? So what we basically do is, try to understand. What we basically do is, here we will say you have been given two states. Say the room initial condition is given. Say for example, with that hygrometer, I took one data here, another data in the computer level. So with that hygrometer, I take two data, one data here, another data in the computer level. So we will get what? One dry bulb temperature, one relative humidity value. So here it may be say 33 or say 30 and say 70% relative humidity. And in the computer lab it will be say about 23 and say 50% or say 45%. Okay, so I am asking you one thing, that you do such a process or perform such a process or conduct such an experiment or process such that you take this air condition or take the air from this condition to that condition. That is the desired condition of air, and this is the actual condition, current condition. So how you will move? So you can understand from this diagram. So say initially it was say higher temperature. Okay. Recording चल रहा है? अच्छा, ये clear तो? हैं? 42 minutes. Yes. बुझी? ये clear? Is this diagram clear? और नाम कितने? और भी good. So is it clear? Now I will try to show. In the last day also I was trying to show in the actual psychometric chart. The carrier isometric psychometric chart also, carrier means that is the company of air conditioning. So I will try showing it on the diagram. अच्छा, तारा ये just इधर discuss करेंगे कौन सा process चलेगा, कौन सा understanding, for your understanding, let me ask you. Say initial condition, can I express this? এটা তো ভিডিওতে শেখাচ্ছি। तो অনই ছিল না। এনিওয়েজ ওই আর কি ফার্স্ট দু একবার মিস্টেক হয়ে যায়। যাই হোক, ভিডিওটা রেকর্ডিং হয়েছে আশা করছি। শোনা যাবে? ওকে okay, now let me ask you one thing, that the starting condition is starting condition is say 33 degree centigrade and 70% relative humidity. That is T If I write this, what is the meaning? Rishabh, what is the meaning? T33 means basically T dry bulb temperature is 33. That we have to clearly understand. When I write the air temperature is 33 means dry bulb temperature, and phi is say phi 1, it is 70%. From this I have to move to say 25 degree centigrade and say 50% relative humidity. Okay. So, what will be the condition? Here it will be TdV, say TdV 1, TdV 1 2 is equal to 25 and phi 2 So, can you plot it manually? Can you plot it manually here in this diagram? Can you plot? Where is the first one? 33 dry bulb temperature, 10, 20, 30, here it is 33 along this line, 30, 31, 32, 33, this line, right? Try to see. You see that actually I should show it here so that everyone can see. Okay. So, 33 is here, 30, 31, 32, 33. So, 33 vertical line, it is constant 33 degree centigrade temperature dry bulb, and 70% relative humidity. You see that 90, 80, 70. So, where that 70 is intersecting the 30, that will be our current state. Clear or not? So, how to identify that point, or how to identify the state of the, how to identify the location of the state here. So, it is 33 in the vertical direction and following the green line. So, where this 70% line is intersecting, that is the state here. Okay. Can you show it? At a pen though? At a black, lal pen? Red? Okay. You see, this is 33. Is it? 33. Here it is 33. 31, 32, 33. Vertical line will be 33 constant dry bulb temperature line. Acha, 70% relative humidity is this one. Is it? This one is the 70% relative humidity line. So, where these two are intersecting? Where? Eta na? You see that this is 33 vertical line and this is 70. It is coming here and intersecting at this point. So, this is the state 1. Okay, state 1. Next, where is state 2? ये देखो 33 इधर है, तुम भी आ जाओ इधर, है तुम भी आओ. Initial temperature is 33. So, 30, 31, 32, 33. So, constant 33, it is the vertical line. And 70% relative humidity, initial condition. So, you see that this is 100%. Saturated line means this is 100%, this is 90%, this is 80%, this is 70%. So, this is the 70% line. So, wherever these two are intersecting, this is the point. You see, you lift it. 33 and 70 intersecting here. So, this is the initial condition, state 1. Okay. Next, state 2 is 25. Where is that 25? 25 is here. So, this is 25. আচ্ছা এবার হচ্ছে 50 কোথায়? Where is that? 50. So, you see
that 25 wherever it is intersecting at the 50 here, right? So this is state 2, 25 degree dry bulb temperature and 50% relative humidity. So this is state 2. Clear? Is it clear? Now therefore I have to bring this air to this air. So how can I do that? So I can join directly here. So it is like it is a kind of what? You see, you can do the. So I have to bring this air up to this condition, from this to this. Okay, clear? Is it clear? Next you see what is that process? So that means you see, from this to this, if I want to bring it, cooling and humidification is required. So you cool it and cooling and dehumidification. So cooling and dehumidification, you cool and dehumidify. That means when you add a cooling coil and the temperature is below the dew point temperature, then there will be some separation of moisture. Or what you can do, you can separate the moisture separately. Okay, separate out the moisture separately and then cool it. The cooling may not be at the dew point temperature itself. So it is not at the dew point temperature. So cooling and dehumidification, that is a combination. So it may be required that you cool the air and dehumidify the air separately and then again mix. Clear? The whole air may not be possible to be cooled and dehumidified fully. The whole air may not be possible to be cooled and dehumidified wholly. So what you can do is, you cool some, say for example, basically next we will see a process called mixing. এরপরে আমরা দেখব mixing, এই যে এরপরে আমরা দেখব এই mixing. Later we will see mixing. Basically what is happening, from this side some air is coming, from this side some air is coming, and then we will mix it to get the desired property. So in how much proportion we should mix so that I get a desired property, because this is the desired property, and এটাও জানা আছে. Now in how much proportion I will mix so that I will get the desired property, we will see it in mixing. Now what we can do is, we take the whole air, then we may dehumidify and then cool it individually, separately, and then mix. So this is the psychrometric chart. in your syllabus it is up to this. ওকে, মিক্সিং এগুলো তোমাদের সিলেবাসে নেই, মিক্সিং পার্টটা তোমাদের সিলেবাসে নেই। তো mixing basically what we do, we have say certain given conditions and the final condition. Basically mixing মানে হচ্ছে কি, there will be mass conservation and energy conservation. So we apply separately mass conservation and energy conservation and we will solve it. That is the process of mixing and that is getting the desired property. So that mixing also can be shown here, okay, because you see that in that condition initial two conditions can be plotted here and the final condition can be plotted. So how to get those that final condition from the starting initial condition, that can be shown here. So here you can just plot and show the process. তবে এখান থেকে আমরা এখানে জয়েন করব, ঠিক আছে, এখান থেকে এখানে জয়েন করলে কুলিং অ্যান্ড ডিহিউমিডিফিকেশন হবে, that will be the cooling and dehumidification. Okay, now basically what we have to do is we have to go for a particular process which is standard process. हाँ, which process you will apply, which process you can do, from that from this psychometric chart you will understand that. So cooling and dehumidification means it will be say following a particular, if you say go for dehumidification first, so what will be done, this will be done, dehumidification at what, constant dry bulb temperature. So how to get it, is it possible, simple dehumidification at constant temperature? Hey, aste constant dry bulb temperature only dehumidification কি করে হতে পারে বলো, সোচো, कर सकते हैं at constant dry bulb temperature only dehumidification we are doing. Here तो है constant dry bulb temperature is there, you are not changing the dry bulb temperature, you are not cooling, you are not increasing decreasing, you are simply dehumidifying. Can you do it? কমাতে হবে dehumidification means moisture will be reduced. मैं तुम बोलो मैं तुमको पूछता हूँ, एयर को क्या करना पड़ेगा, तेज करने से क्या होगा, वो मॉइस्चर निकल जाएगा, मॉइस्चर भाग नहीं पाएगा इतना जल्दी,